Hi and welcome back. So in the past video we were doing this example on apple picking, and we said if we imagine that we had gone out picking apples and the first person had come back with a basket weighing 1.6 pounds, second person's basket weighed 8 pounds, third person's weighed 10.4, and the last person's basket weighed 4.0 pounds, we were trying to figure out what was the weight of one apple based on all of these different weights of the different baskets that we had brought back. And this was assuming that each apple that got picked was exactly going to be the same weight. So we first made a guess, and we just said, like, okay, as a first guess, let's just assume that maybe this person that had the smallest weight for their apple basket, what if they just picked one apple? So we said that our first guess was that an apple weighed 1.6 pounds, or guess 1.6 equals weight of apple. So this was our first guess. And we ran into a problem because when we said that, okay, if we divide these other person's weights by 1.6, if that actually is the weight of an apple, then we should get whole numbers back. There should be a whole number ratio between the weight of each of these baskets and the weight of one apple when we divide the weights by the weight of one apple. And we didn't get that. Instead we got these two numbers that weren't whole numbers. We got 6.5, and then we also got 2.5. Even though the first entry we did get a whole number. So this first person, if an apple weighed 1.6 pounds, would have picked 5 apples. But we knew from these other two people that that wasn't how much an apple weighed. An apple would have had to weigh less than 1.6 pounds. Or I should say that we're trying to find the maximum amount that an apple could possibly weigh. So what we have figured out so far is that an apple has got to weigh less than 1.6 pounds. So now let's think about this. So we've got 5, or our ratios that we found so far were 5. So first person would have picked 5, second person would have picked 6.5, and the third person would, or this is actually the fourth person would have picked 2.5 apples. So let's think, all of these numbers, let's actually just write these as fractions instead. So we're going to say that this is going to be, and let's actually write these all as being fractions over 2. Because these are all going to be, 1/2 goes into these all evenly, right? So if we were going to express this as some fraction over 2, we could say that that's equal to 10 halves, right? Because 5 divided by 1/2 is going to be equal to 10, so this will be equal to 10 halves. 6, how many halves are in 6 halves? Well, it's going to be 13, right? Because 6 times 2 is 12, plus 1 more half. That's going to give us 13 halves. And then finally, we've got, how many halves are we going to have here? We're going to have 2 times 2, so 2 divided by 1/2, plus an extra half, so we're going to have 5 halves here. So now, if we were going to say, let's just imagine that we were off by 2. So we were off by, so this is actually going to be, imagine that 1.6 pounds is actually twice the weight of one apple. So imagine that instead of an apple weighing 1.6 pounds, imagine that an apple now weighed 0.8 pounds. It was actually, so the weight of 1.6 was actually going to be the 1.6, which is the weight of person 1's basket. That would mean that person 1 had actually picked 2 apples, not just 1. So now, how many apples would everyone else have picked? So this is person 1, we already know, and let me actually start making making a little bit of a table. So person 1 would have picked 2. Then person 2, whose the weight of person 2's apple basket was 8.0 pounds. And we knew that if we imagined that that an apple was 1.6, they would have picked 5. But if an apple weighs half as much, they're going to have picked 10, right? So person 2 would have picked 10 apples. How about person 3? So we first imagined that an apple could weigh 1.6 pounds. But now we're guessing that an apple actually weighs 0.8 pounds. So I should say that's what equals the weight of an apple now is going to be 0.8 pounds, and this is our second guess. So what would, if an apple weighs 0.8 pounds, how many apples did person 3 pick? So write down person 3. Well, they picked 6.5 for our first guess. So it's going to be this number times 2, right? Because we're dividing by 1/2. So person 3 would have picked 13 apples. And then person 4 would have picked, our first guess for 1.6 pounds being the weight of an apple, they would have picked 2.5 apples. But now if an apple weighs half that much, we would be dividing this number by 1/2, which is the same thing as multiplying by 2. And now person 4 would have picked 5 apples instead of just picking 2.5. So now, with our second guess being that an apple weighs 0.8 pounds, we've got all whole numbers for how many apples each person could have picked. So this is going to be the weight of one apple. So one apple, or we could say that, an apple could actually weigh less than this. An apple could weigh 0.1 pounds, but let's say that this is going to be the weight of one apple, or this is the maximum weight for one apple. So the weight of an apple, there it goes. The weight of one apple is going to be equal to 0.8 pounds. So for right now, I'm actually going to stop the video here, and in the next video, I am going to show you how this relates to Millikan's oil drop experiment, because I'm sure that you're wondering about this, because this probably seemed like sort of a very, very Algebra 1-like problem, and really it was, and I guess I kind of wanted to show you this to show you that a lot of the stuff that we're going to be learning in chemistry really is repackaged Algebra 1 with some pretty crazy units in it. So in the next video, I am going to explain how this relates to Millikan's oil drop experiment. So thanks for watching, and I'll see you soon.